We will now solve problems using the concepts in projectile motion we described so far. Well, let's start by looking at some of the equations and relations that are important for problem solving. The first thing to do is to identify the initial velocity of projection v0 and the angle of projection theta. The second thing to do is obtain the x component of the velocity, that is v0 cos theta, and the initial y component of the velocity v0 sin theta. Now, the x component does not change. The y component of the velocity will decrease, reaches a zero at the top point, and then decreases. Third, the x position and the y position. Alright, do you know what the x position is equal to? What is the equation for the x position? Since the x velocity remains a constant, the x position will be the x velocity multiplied by the time of flight. So the x position is v0 cos theta t. The y position is v0 sin theta t minus 1/2 gt squared. The horizontal and vertical velocity of the projectile at any given time. Well, the horizontal velocity does not change. How does the vertical velocity change? The vertical velocity Vy equal to Vy0 minus gt. So Vx equal to Vx0, that will not change. Vy equal to Vy0 minus gt, which is Vy0 is V0 sin theta. So Vy equal to V0 sin theta minus gt. Once you have these relations, you can actually solve any problems in projectile. Alright, let's look at a problem. An artillery shell is fired with an initial velocity of 100 meters per second at an angle of 30 degrees above the horizontal. Find A, its position after 8 seconds. Well, its position after 8 seconds will have an x value and a y value. We need to find both. First of all, pick our data. The velocity of projection is 100 meters per second and the angle of projection is 30 degrees. We need to find the x position and the y position after the time t equal to 8 seconds. Well, what is the x component of the velocity? V sub x equal to 100 cos 30 degrees, which is 86.6 meters per second. Vy0, initial vertical velocity, is V0 sin theta, 100 sin 30 degrees, and that is 50 meters per second. Okay. The x position is the x velocity multiplied by time, v0 cos theta multiplied by time, and the x velocity is 86.6, which doesn't change. The time is 8 seconds, so that will be 86.6 multiplied by 8, that is 692.8 meters. And what is the equation for the y position? The y position is v0 sin theta t minus 1/2 gt squared. Vy0 t minus 1/2 gt squared. And Vy0 is v0 sin theta, and you know it is 50 meters per second. So this will be 50 times 8 minus 1/2, g is 9.8, multiplied by 8 squared, the time equal to 8 seconds. And that is 86.4 meter. And so, what is its position after 8 seconds? Its position is 692.8 meter I plus 86.4 meter J. Is that right? Okay. So, in other words, we should be able to write the position at that time as R equal to 692.8 I plus 86.4 J. The position at that particular given time. Alright, let's now do the B part. Find its velocity after 8 seconds. Alright, the velocity after 8 seconds will also have a horizontal component and a vertical component. Well, the horizontal component of the velocity will not change. That will be 86.6 meter per second. How does the vertical velocity change? Vy equal to Vy0 minus gt. So Vy equal to Vy0 minus gt. Vy0, the initial vertical velocity, is 50 meter per second. So that will be 50 minus 9.8 times 8. That is negative 28.4 meter per second. So that is the time the projectile is on its downward journey. The vertical velocity at that time is negative 28.4 meter per second. So how do you now write the velocity? The velocity has an x component, 86.6 meter per second, and a y component, negative 28.4 meter per second. And so this is the velocity of the projectile at that time. We need to find the magnitude and the angle of the velocity. The magnitude is the length of this vector. What is the length of this vector? It will be square root of Vx squared plus Vy squared. So V equal to, the magnitude of V equal to square root of Vx squared plus Vy squared. Vx is 86.6, Vy is negative 28.4, and so that will be square root of 86.6 squared plus 28.4 squared. That is 91.1 meter per second. Well, we also need to find the angle. What is the angle here? If this is the angle theta, tangent of that angle theta will be Vy divided by Vx. Right? So tan theta is Vy divided by Vx, which is 50 divided by, is it 50? No, it will be negative 28.4 divided by 86.6. Is that right? Tan theta is negative 28.4 divided by 86.6. And therefore theta equal to tan inverse of that quantity. Now remember, this is a fourth quadrant angle. Is that right? X is positive, Y is negative. That is a fourth quadrant angle, and the calculator will give it to you directly. If you put this in the calculator gives you negative 37.8 degrees. The velocity of that projectile at that time, at t equal to 8 seconds, is 91.1 meter per second at an angle negative 37.8 degrees with the positive x-axis. Alright. Part C. What is the time required to reach its maximum height? What is the time required to reach its maximum height? Now, we discussed that in our previous lesson. Now, what is the significance of the maximum height. You know, the vertical velocity, that is v0 sine theta, will decrease and will become 0 at the top point. v0 sine theta is the initial vertical velocity that will decrease and will become 0 at the highest point. And so, in order to find the time taken to reach the maximum height, what all we need to do is write down the vertical velocity equation. What is the equation for the vertical velocity? Vy equal to Vy0 minus gt, which is v0 sine theta minus gt. And at the maximum height, what will be the value of that vertical velocity? Will be 0. So we set that equal to 0 and solve for t. That's all we need to do. Vy equal to Vy0 minus gt. Now, when the shell reaches its maximum height, Vy equal to 0. That means we set this equal to 0. That is 0 equal to Vy0 minus gt. And therefore, t equal to Vy0 divided by g. And Vy0 we had calculated early is 50 meter per second. Therefore, that time is 50 meter per second divided by 9.8 meter per second squared. That is 5.1 second. Well, can you tell me now, if the time taken to reach the maximum height is 5.1 second, what is the time of flight of that shell? The time of flight will be double that time. The time taken to reach the maximum height is equal to the time taken to return to the same horizontal level. Alright, we will use that in our next section. What is the horizontal range of the shell? The horizontal range. Now, the horizontal range is the horizontal distance traveled by the shell, which is the horizontal velocity multiplied by the time of flight. And what is the horizontal velocity? This is the horizontal velocity, Vx equal to 100 cos 30 degrees, and you know its value. If you multiply this with the time of flight, what is the time of flight? Well, if the time taken to reach the maximum height is 5.1 second, then the time of flight is double that time, which is 10.2 seconds. There you are. The time of flight is 10.2 seconds. Therefore, x equal to Vx multiplied by t, and Vx is 86.6 multiplied by the time of flight is 883.7 meter. And that is the horizontal range of that shell. Well, this is a representative problem. We discussed practically every aspect of projectile motion in this problem. Let's now look at another problem. A plastic ball that is projected with a velocity of 15 meters per second stays in the air for 2 seconds. At what angle with respect to the horizontal was it projected? In other words, what are the given things? We are told that the projectile was projected with a velocity of 15 meters per second. That is V0. And it stays in air for 2 seconds. That is the time of flight. We know the initial velocity. We know the velocity of projection V0. We know the time of flight. We need to find the angle of projection. Alright, let's set it up. Here we have a plastic ball projected with a velocity of 15 meters per second at an angle theta, and we need to find that angle theta. Now, the velocity has a horizontal component 15 meters per second cos theta, and a vertical component 15 meter per second sine theta. Alright, V0 is 15 meter per second. The x component of that velocity is 15 cos theta, and Vy0 equal to 15 sine theta. I hope you distinguish between the x and y component. The x component does not change, so we don't need to write Vx0. Vx remains a constant right through the flight. So Vx is 15 cos theta, but this is the initial vertical velocity. So we need to indicate it as Vy0. And the time of flight is 2 seconds. If the time of flight is 2 seconds, what is the time taken to reach the maximum height? The time taken to reach the maximum height is 1 second. Alright? Now, at the maximum height, Vy equal to 0. We just used that in our previous problem. And what is the equation for Vy? Vy equal to Vy0 minus gt. There you are. And Vy0 is 15 sine theta, and this t equal to 1. 1 second is the time taken to reach the maximum height. So we have V0 sine theta minus gt equal to 0 at the maximum height. The vertical velocity is 0 at the maximum height. And therefore, I'm going to solve for sine theta from here. Sine theta equal to gt divided by V0. That's okay? Let's leave that equation there. And, well, we know the value of gt over V0. You see, gt over V0, g is 9.8, t is 1 second, V0 is 15 meter per second. Therefore, sine theta equal to 9.8 over 1.5. Therefore, theta equal to sine inverse of 9.8 over 15, not 1.5. Sine inverse of 9.8 over 15, and that is 40.8 degrees. So the angle of projection is 40.8 degrees. That's the first part of the problem. Let's see what the second part is. What is the maximum height reached by the ball? Well, what is the time taken to reach the maximum height? If the time of flight is 2 seconds, the time taken to reach the maximum height is 1 second. Therefore, the maximum height is the y position at that time. What is the equation for the y position? The y position is y equal to Vy0t minus 1/2 gt squared. Alright? The maximum height is the y position of the ball when t equal to 1 second. And the y position is Vy0t minus 1/2 gt squared. What is Vy0? Initial vertical velocity is V0 sine theta. And we know that. V0 is 15, sine theta is 40.8 degrees. So Vy0 is 15 sine 40.8 degrees minus multiplied by the time is 1 second minus 1/2 gt squared. T is 1 second. And that will be 4.9 meter. Alright, let's look at another problem. An arrow was shot at an angle of 55 degrees with respect to the horizontal. The arrow landed at a horizontal distance of 875 meter. Find the velocity of the arrow at the top of its path. Well, the arrow was shot and it rises, reaches the peak, and then goes down. We need to find the velocity at the top. Well, the velocity at the top has only one component. What is that component? The horizontal velocity, because at the top of the path the vertical velocity will be 0. The only velocity at the top of the path will be the horizontal component of the velocity. Well, we don't know the velocity of projection, so it is not very easy. So let's find that first. Well, here is the arrow projected. The arrow goes like this. We need to find the velocity at the maximum height. The angle of projection is 55 degrees. The horizontal range is 875 meters. Well, what is the equation for the horizontal range? The horizontal range is the horizontal velocity multiplied by the time of flight. And the horizontal velocity is V0 cos theta. So, x equal to 875 meters. First, we find V0, the velocity of projection. Without that, we cannot answer this question. So we need to find V0, the velocity of projection. And what is the horizontal range? What is the equation for the horizontal range? This is the equation we developed for the horizontal range. In other words, when you multiply the horizontal velocity with the time of flight and simplify it, this is the equation we arrived at. This is the equation for the horizontal range. X equal to V0 squared sine 2 theta over G. Well, we know theta, we know G, we know X. You see? And so, it's easy now. So, V0 squared equal to, solve for V0 squared. V0 squared equal to x times G divided by sine of 2 theta. There you are. Now, x is known, G is known, theta is known. We use all those values and calculate V0 equal to square root of that quantity. And now x equal to 875 meter, G is 9.8 meter per second squared, and theta is 55 degrees, 2 theta is 110 degrees, and that gives you the velocity of projection is 95.5 meter per second. And you must be able to now do this problem on your own. If this is the horizontal, if this is the velocity of projection V0, what is the velocity at the maximum height? At the maximum height, the velocity is simply the horizontal component, which is V0 cos theta. V0 you know, theta we know, therefore you can find that component of the velocity. Alright. At the maximum height, Vy equal to 0. And its velocity is simply made up of Vx. Vx equal to V0 cos 55 degrees. At the top of the path, Vy equal to 0 and Vx equal to V0 cos 55. Therefore, the velocity at the top is V0 cos 55, and that will be 95.5, and is the value of V0, times cos of 55 degrees, and that is 54.8 meter per second I. It is directed in the x direction. Okay, another problem. Find the angle of elevation theta of a gun that fires a shell with a muzzle velocity of 125 meters per second and hits a target on the same level but 1.55 kilometer distance. Well, what are these given data we have? We need to find the angle of projection theta. We know the velocity of projection V0. V0 is 125 meters per second. What else do we know? We know the horizontal range, the horizontal distance traveled. Alright, the tank fires a gun, fires a shell with a velocity of 125 meters per second, and the horizontal range is, there you are, the horizontal range is 1550 meters. The velocity of projection is 125 meters per second. And the shell comes over here at a distance x equal to 1550 meters. Alright, how do we use these data to find the angle of projection? Well, you know the horizontal range x equal to V0 squared sine 2 theta over g. We used that in the previous problem. Okay? Therefore, sine of 2 theta equal to xg divided by V0 squared. Now that will be g we know, x we know, and V0 we know. All these values you know. Therefore, sine of 2 theta equal to 0.9721. If sine of 2 theta is 0.9721, what is the value of 2 theta? 2 theta is sine inverse of 0.9721, and that will be 76.4 degrees. If 2 theta equal to 76.4 degrees, what is the value of theta? Theta is 38.2 degrees. Okay, let's now talk about another concept or revisit. Remember in the beginning when we started discussing motion, we said all motion is relative. In fact, if an object is moving or not moving depends on where the observer is and what the observer is doing while he is observing. Is that right? In fact, it depends on the frame of reference of the observer. Well, let's spend some more time talking about that concept, relative velocity. All velocities are relative. It depends on the frame in which the measurement is being made. If you are driving in the positive x direction at 20 meters per second, a passenger sitting next to you will see you at rest, while a person standing on the roadside will measure your velocity as 20 meters per second I, because you're going in the positive x direction. Is that right? So you are in the car is moving due east towards the positive x direction with a velocity 20 meters per second. You look at your friend in the passenger seat and say, hey, you are at rest. But your friend standing outside looks at the passenger and say, the passenger in the car is moving in the x direction with a velocity 20 meters per second. Is that right? Yes. So the person outside will see the person in the car moving due east or in the positive x direction with a velocity 20 meters per second. A person in a car moving in the negative x direction. Alright? Now you are in the car that goes east. Another car is going west in the opposite direction. A person in a car moving in the negative x direction at 15 meter per second will measure your velocity, and what will that velocity be? You see, that person will see you moving away from him at 35 meter per second. Have you understood that? The person in the second car is moving west and you are moving east. So the person in the car that is moving west will see you moving away from him at 20 plus 15, that is 35 meter per second. In fact, the distance between your car and his car is changing at the rate of 20 plus 15, 35 meter per second every second. And that is why we say the person in that car will measure your velocity as 35 meter per second I. Now that means when that person measures your velocity, that is measured relative to his frame of reference. Is that right? A person outside will measure your velocity at 20 meter per second I. That is from this frame of reference. A person in the other car that moving west will measure your velocity at 35 meter per second, and that measurement is made from the frame of reference of that second car. So the velocity that you measure depends on the frame of reference from where the measurement is made. Yet another person in a car traveling in the positive x direction, suppose there is a third car that is passing you in the same direction and he is moving at 25 meter per second. You see, your velocity is 20 meter per second I, and the car that is passing you is passing at 25 meter per second. Now tell me, if that person measures your velocity, what will be your velocity? In fact, every second you are moving 20 meter, every second the other car is moving 25 meter. That means the distance between the two cars is increasing every second by 5 meter. That means the velocity of your car measured from the passing car will be 5 meter per second in the opposite direction. Your car will appear to be moving backward from the car that is passing you. I hope you understand that. So another person in a car traveling in the positive x direction at 25 meter per second will measure your velocity as negative 5 meter per second I. Now, when I was discussing the relative motion, I showed you an animation. Let's go back and look at that animation one more time to understand relative motion and frame of reference. Now, what is the frame of reference now? The frame of reference is the ground. Now, let's give some values here. When you are standing on the ground, let's say the man is walking in the x direction with a velocity 1 meter per second. Is it okay? We will just assume that. So let me write that down here. So we say velocity of man is 1 meter per second. Let's say the velocity of the river is 3 meter per second. And velocity of the boat is 5 meter per second. We're just assuming these values. Okay. Alright, let me write that again. Now, what happens when you move the reference frame? when you move from the ground to the river, you can see the river is at rest. The river is the frame of reference. So what we did here, what was the velocity of the river? We said the river is flowing down with a velocity 2 meters per second when you observe from the ground. And now when you are in the river seems to be at rest. That means in order to bring the river to rest, we applied a velocity 2 meters per second to the river in the opposite direction. You see, originally we saw the river moving down at 2 meters per second. Now, when you are in the river, you brought the river to a stop. That means you applied a velocity of 2 meters per second in the opposite direction. And now, the velocity of every object from the river will be having the same effect. Apply everything else a velocity 2 meters per second in the opposite direction. Now look at this. The man originally we said was moving 1 meter per second to the right. And now you see him moving 1 meter per second to the left. That means when you brought the river to a stop by applying an equal and opposite velocity of the river, 2 meters per second to the left, you apply that velocity to every object. When you apply that velocity to the man is now going 1 minus 2, that is negative 1 meter per second to the left. And from the ground you saw the boat was moving at 5 meters per second. When you came down to the river, what is the velocity of the boat measured from the river? You see, to bring the river to a stop, you applied an equal and opposite velocity to the river. And you need to apply that velocity to every other object. So apply that negative 2 velocity to the boat. The boat now has a velocity 5 meters per second down and negative 2 meters per second up. And the net velocity is 3 meters per second. So when you observe it from the river, the boat will appear to be moving with a velocity of 3 meters per second. And watch my language. The velocity of the boat measured from the river is 3 meters per second, 5 minus 2. And we call it the velocity of the boat with respect to the river. The velocity of the boat with respect to the ground is 5 meters per second. The velocity of the man with respect to the ground is 1 meter per second I. And the velocity of the man with respect to the river is negative 1 meter per second I. And now, if I want to measure the velocities of all these things from the boat, what do? I bring the boat to a stop. You know, when I observe it from outside, alright, let's go outside again. When I observe from outside, the velocity of the boat is 5 meters per second. And to bring it to rest, what do? Apply a negative 5 meters per second to the boat. Now the boat will come to a stop. Now to find the velocity of every other object from the boat, you have to apply that negative 5 meters per second to everything. That means, tell me, what will be the velocity of the man if you measure it from the boat? Now, first of all, bring the boat to a stop by doing what? By applying a velocity, applying its velocity equal and opposite. Negative 5 meters per second to the left. Boat comes to a stop. Apply the same velocity to the man, negative 5 meters per second. And now, the man has two velocities. his actual velocity 1 meter per second to the right, and now the imposed velocity negative 5 meter per second to the left. So when you measure it from the boat, he will appear to be going left at 4 meter per second. Alright, let's go to the boat and bring the boat to a stop. Look at this. When you measure the velocity of the boat, velocity of the man from the boat, he is rushing in the negative x direction at 4 meter per second. Is that right? So this is what we're going to do to find the relative velocity. We are finding the relative velocity of the man with respect to the boat. Right? Now, if I want to find the relative velocity of the boat with respect to the man, what do? I go and bring the man to a stop. Alright? Let's find the relative velocity of the boat with respect to the man. Alright? Now, tell me again. When we observe from outside, what is the velocity of the man? 1 meter per second I. What is the velocity of the boat? 5 meter per second I. Alright, now I want to find the relative velocity of the boat with respect to the man. That means the man is now the frame of reference. So what do? Bring the man to a stop by applying 1 meter per second in the opposite direction. That means you got to apply the same to the boat. The boat will now have a velocity 5 meter per second down and 1 meter per second up. So the man will measure the velocity of the boat as 5 minus 1, that is 4 meter per second I. There you are. Let's go and bring the man to a stop. There you are. We are now measuring the velocity of the boat. Well, I think I need to move it. Give me a second. I want the man to come over so that I can find him. Okay. Let's wait for the man to come over so that we can find him. And bring him to a stop by applying 1 meter per second in the negative x direction. There, the reference frame now is the man. We brought him to a stop by applying an equal and opposite velocity of his, which is 1 meter per second in the negative x direction. Apply the same velocity to the boat. So what is the velocity of the boat now measured by the man? It will be 5 minus 1, which is 4 meter per second. Okay, let's go and put these things in writing. Now, how do we measure the relative velocity of A with respect to B? What is the meaning of that? The relative velocity of A with respect to B. It means the velocity of A measured from the frame of reference of B. That is the meaning, the relative velocity of A with respect to B. Now, what did we say in our animation there? To measure the velocity of A with respect to B. You see, whichever frame of reference you are using, you need to bring that frame of reference to rest by applying an equal and opposite velocity to both objects. So if you want to measure the velocity of A with respect to B, you got to bring B to a stop. Alright, let's write that down. If two objects A and B are moving, the velocity of A relative to B is obtained by the following two steps. What is the first step? Impose a velocity equal and opposite to that of B to both A and B. Why do we do that? In order to bring B to a stop. B is our reference frame. The reference frame is brought to a stop. So impose a velocity equal and opposite to that of B to both A and B. This will bring B to rest and give A two velocities. One its own velocity and the other the equal and opposite velocity that you imposed on it. And then what do? So if this is A moving east at 50 meters per second, and this is B again moving east at 60 meters per second, and you need to find the velocity of A with respect to B, what do? Bring B to rest by imposing an equal and opposite velocity. So impose on both of them negative 60 meters per second. That will bring B to a stop. And when the same velocity is imposed on A, now A has two velocities, 50 meters per second I and negative 60 meters per second I. Now what is the resultant of these two? It will be negative 10 meters per second I. So when you measure the velocity of A from the reference frame of B, A will appear to go back at 10 meters per second. That's the meaning there. So then find the resultant of the velocities of A and B. So the relative velocity of A with respect to B is now the resultant of these two velocities. That will be 50 meters per second I minus 60 meters per second I. That is negative 10 meters per second I. This is the same example of you going in the east direction and another car passing you, and the person in the passing car will see you moving back. The same example. Okay, let's do this now. Car A has a velocity of 10 meters per second I, and car B has a velocity of 15 meters per second I. Find the velocity of A relative to B, and 2, the velocity of B relative to A. So in the first case, we need to find the velocity of A relative to B. Means B is the reference frame. You need to bring B to rest. In case 2, the velocity of B relative to A means A is the reference frame. You need to bring A to rest. Alright, let's see. Car A is moving east at 10 meters per second. And car B has a velocity of 15 meters per second. Alright, we need to find the relative velocity of A with respect to B. B is now the reference frame. So bring B to rest by imposing a velocity of negative 15 meters per second I to both A and B. So impose a velocity negative of the velocity of B to both A and B. So the velocity negative 15 meters per second on B and a negative 15 meters per second on A. What does it do to B? B is now brought to rest. And what is the resultant velocity of A? It will be 10 minus 15, that is negative 5 meters per second. So the resultant velocity of A is negative 5 meters per second I. What does it mean? When you measure the velocity of A from B, A will appear to be going back with a velocity of 5 meters per second. That is the meaning there. Alright, let's do the part 2. In part 2, we need to find the velocity of B with respect to A. So this time A is the reference frame. So we need to bring A to rest. So bring A to rest by imposing a velocity of negative 10 meters per second to both A and B. So here negative 10 meters per second imposed on A and negative 10 meters per second imposed on B. And now A comes to a stop, that is the reference frame. And what will the velocity of B then look like? It will be the resultant of these two, which will be 15 meters per second minus 10 meters per second, and that will be 5 meters per second I. So when you measure the velocity of A from the car B, when you measure the velocity of B from the car A, car B will appear to go in the positive x direction at 5 meters per second. In other words, what it means is the overtaking car, the passing car, the distance between the two cars will increase at the rate of 5 meters per second every second. 5 meters every second. Alright, let's now do another problem. A swimmer maintains a speed of 0.15 meters per second relative to the water when swimming directly towards the opposite shore of a straight river with a current that flows at 0.75 meters per second. How far from the stream is the swimmer carried by the current in 1.5 minutes? What is the velocity of the swimmer relative to the observer on the shore? Well, you can understand that problem. There's a river flowing and the swimmer is going across the river. Now you can see the swimmer tries his own. He's got a velocity of his own. What is the speed of his swim? It's 0.5 meters per second. But the river is flowing. That means the swimmer is subjected to these two velocities. The swimmer has his own velocity and also the velocity of the river. The swimmer is being carried downstream by the river. Okay, let's set it up. Now here is the beautiful river and the swimmer is trying to cross the river. While the swimmer is trying to swim across the river, he is also carried downstream because of the velocity of the river. Now, the swimmer has now got two velocities. What are the two velocities the swimmer now has? 0.15 meters per second, which is the velocity of his swim, which is right across the river, and 0.75 meters per second, which is the velocity of the river. Can I draw these? Now, this is the velocity of the river. That is 0.75 meters per second. Now, this velocity is imposed on the swimmer. And where do I draw his own velocity? His own velocity is 0.15 meters per second. Now look at this. He is now subjected to these two velocities, and therefore his velocity as observed by an observer outside on the shore will be somewhere this way, the resultant of these two velocities. The velocity Vx equal to 0.75 meters per second takes him downstream, and the velocity Vy equal to 0.15 meters per second will carry him across the river. These two velocities are independent of each other, just like a projectile. The horizontal velocity will not be affected by the vertical velocity. Alright? Now, A. The distance the swimmer moves downstream is purely due to the velocity of the river. And that will be 0.75 meter per second multiplied by the time. Now, what is the first part? We need to know how far the swimmer has been carried in 90 seconds, in a minute and a half. Now, the distance the swimmer moves downstream is the downstream velocity, which is Vx, multiplied by that time. That is 0.75 meter per second multiplied by 90 seconds. That is 67.5 meter. In a minute and a half, the swimmer is carried downstream by a distance of 67.5 meter. The velocity relative to the observer is the resultant of these two velocities. When an observer looks at the swimmer, he will not see the swimmer going exactly down. He will not see the swimmer going exactly across the river, but he will see the swimmer going at an angle somewhere that way. And that is the relative velocity of the swimmer with respect to the man observing from the shore. Alright, so this is what the relative velocity of the swimmer is. We need to find the magnitude, that is the length of this vector, and the angle theta. The length of the vector will be, what is the length of the resultant vector? Square root of Vx squared plus Vy squared. And that will be square root of 0.75 squared plus 0.15 squared. That is 0.765 meter per second. And what is the angle of that velocity? We have been doing these so many times. You can say theta equal to tan inverse of Vy divided by Vx. Tan theta equal to Vy divided by Vx, which will be Vy is 0.15, Vx is 0.75, and therefore theta equal to tan inverse of Vy divided by Vx. And what is that angle equal to? That is 11.3 degrees. So for an observer looking from the shore will see the swimmer moving with a velocity of 0.765 meter per second at an angle 11.3 degrees, the positive angle measured from the shore. Well, that is the velocity. I think we did a number of representative problems from projectile motion and relative motion. Is that right? Alright, let's look at one more problem. A ball thrown into air lands 40 meters away 2.44 seconds later. Find the direction and magnitude of the initial velocity. Well, we need to find V0, the velocity of projection. What do we know? We know the range of the projectile. It falls 40 meters away from the place it is projected, and the time of flight is 2.44 seconds. So let the velocity be V at an angle theta with the horizontal. We don't know the velocity of projection. We don't know the angle of projection. Alright? So let the velocity of projection be V. Normally we call it V0. Let's call it V this time. And the angle of projection is theta. Alright? Here is the object. It is projected with a velocity V at an angle theta. There it goes. Okay. Now the horizontal component of the velocity Vx0, which is the same as Vx, will be V cos theta, is that right? And the vertical component will be V sin theta. The initial x velocity Vx equal to V cos theta. Now, did I really have to call it initial? Well, this is the initial and also the final, because the x velocity will not change. And Vx remains a constant. The initial y velocity, yes, we got to say that the initial, because y velocity keep on changing. Vy0 is V sin theta. Well, x equal to Vx multiplied by time. The horizontal range is the horizontal velocity multiplied by the time of flight. Now, the horizontal range is 40 meters and the time of flight is 2.44 seconds. So we have 40 equal to V cos theta times 2.44, and that gives us one equation. V cos theta equal to 16.4. V cos theta equal to 40 divided by 2.44, or V cos theta equal to 16.4. Now, Vy0 at the maximum height, what is the vertical velocity when it reaches the maximum height? The vertical velocity will be 0, and what is the time taken to achieve that? Half the time of flight. The time taken for the projectile to reach the maximum height is half the time of flight. If 2.44 is the time of flight, the time taken to reach the maximum height is 1.22 seconds. And at that time, the y velocity will be 0. And what is the expression for the y velocity? The y velocity Vy is Vy0 minus gt. Is that right? So Vy equal to Vy0 minus gt. And this Vy0 is V sin theta. Alright. So we're going to say this Vy will be equal to 0 when this t equal to 1.22 seconds, half the time of flight. So look at the equation we produced. 0 equal to V sin theta minus 9.8 times 1.22. We can now obtain a value for V sin theta. Can you solve for V sin theta from there? Well, I have solved. V sin theta equal to, take this to the other side, 9.88 times 1.22, that is 12. Okay, let me see how much mathematical background you can use to solve this problem. What we are looking for, we need to find the value of V and the value of theta. And we have two equations. V cos theta equal to 16.4. V sin theta equal to 12. Can you find the value of theta from here? If you know your trigonometry, you know that sin theta divided by cos theta is tan theta. So what happens if you divide equation 2 by equation 1? I hope you understand what I'm saying. Divide the left hand side of equation 2 by the left hand side of equation 1, and divide the right hand side by the right hand side of equation 1. So what do we get? We get V sin theta divided by V cos theta. Is that right? V sin theta divided by V cos theta. V and V will go. Sin theta divided by cos theta is tan theta. Now, V sin theta divided by V cos theta is 12 divided by 16.4. So we get tan theta equal to 12 divided by 16.4. and therefore theta equal to tan inverse of this number, that is 36 degrees. You see how beautifully we were able to get that angle theta. And now that you have the angle theta, you can find the value of V. V can be obtained from any of these equations. I used this one. I said V equal to 12 divided by sine theta, 12 divided by sine of 36 degrees, that is 20.4 meter per second. Well, the study of projectiles is an interesting and very fascinating subject, because we see projectiles all around us, and we only talked about some rudimentary, basic, fundamental aspects of it. Alright, I want you to learn these concepts and learn how to solve problems. Okay, and I think we have come to the end of Unit 1, if I'm not mistaken. That means you are now ready for your Test 1. Remember, at the end of each unit, you have a practice test. So look at the practice test, make sure you can do all the questions, and then go and do your test. Okay? I will get back to you with the next lesson later on.